Last time we looked at square root functions, and today we're going to look at cube root functions. But before we go into cube root functions, let's start with cubics, just to refresh our memory. So let me look at x cubed. So f of x equals x cubed will be our parent function for cubics. Now, if I'm cubing something, I can cube negatives and I can cube positives. So we'll make a nice table for this one. So let's go from -3 to 3. So if I take -3 and cube it, -3 times -3 times -3 gives me -27. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. And 3 cubed is 27. So let's make a graph of x cubed. Now, probably won't make it all the way to 27, so that's okay. So let's see, put this kind of in the middle here. My x-axis and my y-axis. We need to get all the way to 8, huh? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's -8 and a +8 for our y's. I'll just graph these because 27 is really far out there. 1, 2, 3. 1, 2, 3. So let's plot our points. Now we'll leave off the -3 and the +3 because those are too big for our graph. So -2 goes to -8. -1 goes to -1. 0 goes to 0. 1 goes to 1. 2 goes to 8. We get this kind of swervy thing. I think some people called it the Egyptian-looking thing. What's the domain of our cube root function? Well, I can plug in negatives, I can plug in positives, so it's really everything. So my domain is all real numbers. It's -infinity to +infinity. What's my range going to be? Well, the range is also going to be -infinity to +infinity. It's everything. Now, we're going to be getting into cube root functions in just a second. And to find that, we're going to be switching our x's and y's. So we'll get kind of a feel for what's going on. But before we go there, let's think about transformations of even x cubed. If we had g of x equals, let's say, x minus 2 cubed plus 4. What do you think would happen to that parent graph if we changed it to that? Knowing what we know about transformation. Well, the x minus 2 is going to move it right 2. The plus 4 is going to move it up 4. What's that going to do to our domain and range? Absolutely nothing. It's going to stay all real numbers. The domain is still going to be -infinity to +infinity, and my range is still going to be -infinity to +infinity. Let's look at a little bit harder one. I'm going to change colors here. Now we'll keep it red. G of x equals 2x cubed minus 3. What if it had a 2 in there? Oh, we don't like that, do we? Well, can I separate that out? That's really 2x times 2x times 2x. That's really 2 cubed times x cubed? Well, 2 cubed is 8. So this is really 8x cubed minus 3. Great. What's the 8 do? Oh, that's a vertical stretch by 8. What's the minus 3 do? Down 3. What's going to happen with my domain and range if I stretch this and just slide it down 3? Actually, nothing happens. Negative infinity to infinity, and the range is also negative infinity to infinity. Now let's go for the inverse. So, the cube root of x. So let's think about some of those perfect cubes. So when we're taking the cube root, we know where we're headed. So we're going to look at the parent function of the cube root of something. Well, if I switch my x's and y's, I'll really get it. And I'm just going to switch the ones that we used, which was the negative 2, negative 8. When I switch that, that's going to be negative 8. Cube root of negative 8 is negative 2. The next one was negative 1. Cube root of that is negative 1. 0, 0. 1, 1. 8, 2. Cube root of 8 is 2. Look what happens on our graph. So this time my x-axis has to go between negative 8 and 8, and my y's only have to go from negative 2 to 2. They switched. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. Beautiful. So, negative 8, the cube root of that is negative 2. Negative 1, negative 1. 0, 0. 1, 1. 8, 2. Now, you might also want to put these in the calculator. So let's look at how we would do that. So if we do that, to put the cube root in our calculator, we've got to do y equals and cube root. Okay, so cube root isn't on our calculator here, but if you go to the math button, you get a lot of good options. First off, number 3 is cubes. So if I wanted to cube something, I can get a number 3. The next one down, the 3 in front of the radical, is the cube root. Now number 5 is where you could put any one in there, but we're just going to go to number 4, and notice it gets the cube root of x. And let's look at the graph. Does it match what we drew? Yep, it sure does. Notice that it's basically like taking this one, flipping it, and turning it sideways. If I laid them on top of each other, that big one would go like this. And notice you'd have that symmetry about the line y equals x. So ignore that one. This is my cube root. So let's do our domain and range. The domain of this cube root function, well, it's going all the way that way, going all the way that way, negative infinity to infinity. The range of that function, guess what? Negative infinity to infinity. You're going to love cube roots because they do work really nicely together. So let's look at some of these and see what we can figure out. What if I had, let's see, g of x equals 2 times the cube root of x plus 4 minus 7. Now, I could put it in the calculator to try to figure it out, but I think we can do it from here. What does the 2 do? That's going to be a vertical stretch by 2. X plus 4. Left, 4. Minus 7 at the end. That's moving it down 7. One of the really nice things about cube roots and cubics is that even if you shift them up and down and stretch them and all that stuff, it really doesn't affect the domain and range. The domain is still negative infinity to infinity, and the range is still negative infinity to infinity. Okay, let's do one more. One of the hard ones. What's going to happen if we have the cube root of negative 4x plus 3? Oh, darn it. Can I take cube roots of negatives? Oh, I sure can. I don't like that negative 4 in there, though. So what is that going to do? Let's see. Cube root of a negative number ends up being a negative. And that's going to be the cube root of 4 times the cube root of x plus 3. So what all is happening? What's the negative going to do? Well, that's going to reflect over the x-axis. What's this cube root of 4 going to do? That's going to be a vertical stretch by the cube root of 4. And then the plus 3 at the end moves it up 3. What's going to be my domain and range? Well, that's easy. Negative infinity to infinity and negative infinity to infinity. Love cube roots. One of the other nice things is, since it does work for all numbers, our domain and range is always all numbers, then when we're checking these, we should come out with good answers every time. There's not even a possibility of an extraneous solution. So speaking of solutions, let's look at some equations. So let's see. This is example 1. 2 times the cube root of 2x minus 1 equals 6. I'm making its problem up, so I hope it works out. Okay, so let's see. Well, we want to isolate the radical because that's what we did last time. So to isolate the radical, in other words, isolate that root. So divide by 2, divide by 2. Now when I do this, it's only dividing that 2 that's on the outside. So I'll be left with the cube root of 2x minus 1 equals 3. Now last lesson, if we ended up with a radical equals a number, we squared both sides. But is squaring a cube root going to work? No. To undo a cube root, we need to cube both sides. So each side, we're going to cube. When I cube a cube root, they're inverses, they undo each other. That's going to be 2x minus 1 equals 27. Now it should be nice and pretty. Solve for x. So to solve for x, I need to add 1 to both sides. And then divide by 2. Now, I still suggest checking your answers, but we really shouldn't have an extraneous solution. So checking your answers here is just really to make sure that you're right. So if I'm going to go back in and check my answer, I'm going to plug 14 back into here. So 2 times the cube root of 2 times 14 minus 1, and let's see if it equals 6. Cube root of 2 times 14 is 28 minus 1. Cube root of 28 minus 1 is 27. The cube root of 27 is 3. Does 2 times 3 give me 6? Yes. So I do suggest checking your answer just to make sure, well, that you got the right answer, but you're not having to really look for extraneous solutions. Let's do another one. Let's see. Ooh, yeah. What if I do that weird notation stuff? So let's see. What if I have 4 plus x minus 1 to the 1/3 equals 2. Well, 1/3 really means the cube root of x minus 1. So now we just isolate the radical. So I'm going to subtract 4 from both sides. To undo something the cube root, we need to cube it. Cubing a cube root will undo them. So we'll have x minus 1 equals negative 2 cubed is negative 8. Add 1 equals negative 7. We can check just to make sure. I like plugging in to this version. 4 plus the cube root of negative 7 minus 1, does it equal 2? Cube root of negative 8. Well, the cube root of negative 8 is negative 2. And 4 plus a negative 2 does equal 2, so it checks out. And that's basically it. Your quiz, you will have to describe the transformations, give me the domain and range, and solve a couple equations.